and segregate some and keep them in Q2. So what it is doing, it is actually remembering which are the valid inputs, which are the invalid inputs, and why if some inputs are invalid, they are invalid. Why यानी कुछ input Q0 में जाने के कारण invalid है, कुछ input Q1 में जाने के कारण invalid है. So why is 10110 invalid? Why is it is invalid? Because अगर ये 101 होता तो वैलिड हो जाता. उसके बाद prefix आया 10. That 10 prefix has made it go away from this particular state. Okay, so it's a property of strings that is actually making these strings look different from each other or look similar to each other. Now if I had input 1 1 and then all zeros, so if I had input 1 1, okay, starting with 1 1 prefix, and then there would be all zeros, एक या एक zero हो, दो zero हो, या कितने भी zero हो. Okay, I may have any number of zeros afterwards. All such inputs are valid inputs as far as this device is concerned, because you are going to end up in Q2. You are going to end up in Q2 for all those inputs. But if after two ones there is a third one in input as a prefix, third one in the input as a prefix, then you are not being in Q2. Q2 से बाहर निकल जाते हैं. सिर्फ एक वन है इनिशियली इन प्रेफिक्स, यू स्टिल आर नॉट गेटिंग टू Q2 स्टेट. सो Q2 स्टेट में पहुंचने के लिए मेरे स्ट्रिंग में दो वन होने जरूरी है. वो दो कंसेक्यूटिव हो सकता है या नॉन कंसेक्यूटिव. कैसे? आई कैन स्टार्ट विथ वन, आई मे हैव सम जीरोस इन बिटवीन एंड देन आई मे हैव वन. सो दो वन आने के बाद मैं Q2 में पहुंच जाता हूं. वेदर दो वन शुरू में आए या शुरू में कुछ जीरो आए, उसके बाद एक वन आए, उसके बाद कुछ जीरोस आए, उसके बाद कुछ वन आए, दोनों कंडीशन में अगर दो वन है स्ट्रिंग में तो मैं जरूर Q2 में पहुंचूंगा. थिंक ऑफ एनी स्ट्रिंग दैट हैज टू वंस. यू स्टार्ट विद 0 1 1, you will reach Q2. You start with 0 1 0 1, you will reach Q2. You will start with 0 0 1 1, you will reach Q2. You will start 1 1 0 0, you will reach Q2. You will start 1 0 1 0, you will reach Q2. See, this is an arbitrary automata. ये मेरा दिमाग में भी नहीं था at the beginning when I draw the automata. It's just a drawing per se, a graph. But now that we started understanding the properties, we started understanding that Q0 is a state which is storing either zero number of ones or more than two number of ones. Right? Okay. Any string that has initial part में two ones वो हमेशा Q2 में जाएगा. तीन वन वाला कभी भी Q2 में नहीं पहुंच सकता, लेकिन चार वन वाला पहुंच जाएगा. वन वन के बाद फिर से रिटर्न आने के लिए पांच वन होने चाहिए, सॉरी दो फोर नहीं फाइव होने चाहिए. सो वन वन के बाद when I go back to Q0, I again need a 1 1. I again need two ones to get back to Q2. So there is some property related to this count of ones again. And again, it's a property of input string that we are trying to represent through this automata. Please understand it. ज़्यादा कुछ दिमाग लगाने की जरूरत नहीं है, because I'm not going to ask you right now in today's session कि ये कौन से string को accept करता है या इस particular automata का language क्या है. Now, this question that I've asked is important. ऐसे हम लोग हर एक string के लिए बता सकते हैं कि whether the string is acceptable or whether the string is non-acceptable by simulating it. Now, if I start collecting all the strings which are acceptable string, then that collection of strings is referred to as language of this particular automata. So now this is another concept that you need to understand. So Friday lecture I'll be throwing more light on what I'm talking about today. I'll just say that if this automata is M, then the set L of M is a set of all W's, okay, such that W belongs to sorry, I should write it rather than writing it like this. I forget and I'm actually lazy to open that part. Sorry for that. L of M is a set that is defined as set of W's, where W is one string. So how do I represent W as a string? W belongs to, I represent it as a string as I say W belongs to. मेरे पास small e नहीं है. This is epsilon by the way. Belongs to का symbol है. I'll write it afterwards. Sigma. So I need to write it. This इतना छोटा मैं लिख नहीं पा रहा हूँ. Sorry for that. Next time I'll actually bring the symbols. Symbols are there in Word, so I need to bring them. Okay. Let me bring some symbols for you. Without symbols, it becomes difficult to write. So insert symbol, special characters. Epsilon. So this is belongs to character. What else I'll require? I require a sigma. Insert special character sigma. Brought all these last year as well, but then I forgot. The current काम हो जाएगा. Just put them on somewhere on the board. So now I can use them as they come to my board. Okay, fine. So just copy this. What I want to write is W belongs to sigma. इतना मेहनत मैं नहीं करना चाहता था. And there is a star for it, sigma star. So now what is this star? We'll come to that discussion in a bit. So LM is a set of W's where W belongs to sigma star. Okay, that is W is a string. इसका मतलब है W एक string है. ये कैसा string है? And the other property is W is accepted by M. Okay, so this is the definition for L of M. So L of M का English meaning क्या है? Language of automata M. Language of automata M is collection of all the strings which are accepted by that particular automata M. Automata M में जो भी automata M से जो भी input strings acceptable है, उन acceptable string का collection is referred to as language of that particular automata. ओके, सो हमने आज क्या क्या देखा? हमने आज देखा कि एक ऑटोमेटा को फाइनाइट ऑटोमेटा कहलाने के लिए यू शुड डिफाइन 5 थिंग्स अबाउट दैट पर्टिकुलर ऑटोमेटा. दोस 5 थिंग्स आर फाइनाइट सेट ऑफ स्टेट्स, फाइनाइट सेट ऑफ इनपुट सिंबल्स, a transition function which is mapping between current input current state to next state. Then I should define a particular state as initial state and particular set of states as final states out of Q. Then that device will be referred to as an automata or finite automata. For a finite automata, when I actually provide an input to a finite automata, it always starts its processing through state number Q0. It assimilates or accepts one character at a time from input from left to right. As it processes every character, it it checks with the transition diagram or transition table, which is the next state every time it processes one input. And then it produces a state in which the device will land after the input is completely processed. Okay, based on whether this state which it has reached is final state or not, you decide whether the input is accepted or input is rejected. When the input is accepted, if I collect such all inputs into a set, that set would represent the language for the given automata. Now this way the concept of language abstraction marries with the device automata, finite automata. अभी तक हमने language abstraction independently देखा था और अभी हमने ये जो कंस्ट्रक्शन देखा है, अभी जो हम लोग डिस्कस कर रहे हैं फाइनाइट ऑटोमेटा, इन दोनों का हमने नाउ एक साथ कर दिया दोनों कंसेप्ट को. Till now we were independently learning these two concepts. Finite automata was for us a device that was using language abstraction in a form that language से string बनता था, string use करते थे, right हम लोग. तो ये वेरियस स्ट्रिंग जो एक्सेप्टेबल है फाइनाइट ऑटोमेटा के, वो मैं एक साथ ले लूँ तो एक सेट बनेगा, सेट ऑफ स्ट्रिंग. This set of string, now I am telling you that is it is referred to as the language for that particular automata. We also know the fact that states are, or the finite states that we say, are mechanisms of this device to remember certain types of inputs which are in having certain characteristics common. Common characteristic वाले inputs को वो एक साथ लेके रखता है. That is what this particular state concept is actually about. It is trying to partition all set of inputs that I can flash on or that I can provide on this particular device. It partitions them into different subsets, and these different subsets themselves are sets of strings which are taking me to those states. Okay, so this is what is the concept of states. Okay, now अभी तक मैंने डिवाइस एक्चुअली ऑर्गेनाइज कैसे होगा, या ये डिवाइस अगर आपको फिजिकली देखना है तो कैसे रहेगा, इसके बारे में कुछ नहीं बताया था. सो नाउ आई विल एक्चुअली टेल यू हाउ विल दिस डिवाइस बी वर्किंग, what components this device would have. ये विजुअली हम लोग थोड़ा देखने की कोशिश करेंगे. So this device will actually have a tape kind of an input which will have cells. In each cell there will be one character for the input that can be written. This tape will be considered as an infinite tape. Okay, इनफाइनाइट लेंथ का टेप कंसिडर करेंगे, क्योंकि इनपुट का लेंथ भी इनफाइनाइट हो सकता है, बिकॉज इनपुट इज जस्ट अ कॉम्बिनेशन फ्रॉम अल्फाबेट. कितना भी लेंथ का इनपुट आप थ्योरेटिकली दे सकते हो. अगर मेरा इनपुट सेट 0 1 है, so this is how I will be actually giving input to my device. Okay, this is how I will be giving input to my device. Okay, now my device will have a read head. Okay, COA सीख रहे हो तो I guess you know the concept of read head. Read head मतलब you can only read, you cannot do write operation, and this read head can only process one cell from the tape at a time. One cell on the tape at a time this read head can process. This read head can move one cell to the right at a time. So at a time, after reading one symbol, the tape head moves itself to one cell to the right. So this is the movement that the read head is having. Okay. Next, this device has a thing called as transition table, which is a lookup table. Okay, I don't need you to tell what it is. The device also remembers a variable that remembers the current state. So this is what it remembers. It remembers what is the current state. Okay, there is a persistent variable. Then when it reads this symbol, it can remember for time being what is read. So I'm writing, noting that as an A. So I can just read what is there on the tape. So this 0 comes over here when the head is pointing to 0. Okay. Now what this device is capable of doing is, it is capable of using these two as an index to do a lookup into this table. So it will do a lookup into this table. So I'm just now talking about the organization of this device. It can do a lookup into the table. As it does the lookup, what it will know? It will know the state, and it will update the state. So it will know the state. So output will be what? A new state that the device goes to. Okay, so that's why I'm mentioning it to be QJ. This is QI. This is lookup. Lookup is giving me QJ, and I'm doing what? This is what I'm updating. So I'm just removing QI, and instead of QI, I'm putting new state QJ in that place. And this is what the device is going to do. So what are the device operations now in this way if the device is organized? First operation that the device is going to do is to read this symbol, update this with that value. Okay. Second thing it is going to do is to do the lookup. Third thing it does is get the next state and update it with respect to this persistent variable. Fourth thing it does is take this particular thing. So this particular thing is fourth. Sorry, this thing is fourth. Take this tape head to the next cell. So 1, 2, 3, 4. These 4 operations continuously done by this device, and that is how the input is processed. When the input is processed completely, suppose how do I understand that input is processed? Suppose that this input ends over here, then there will be an empty string. Okay, अरे अपने पास epsilon है अभी. I just need to bring it. Okay, I did not had the epsilon earlier ना, तो अभी अपने पास epsilon है. Just bring it to this page. Okay, ऐसे ही करना पड़ता है because I'm not a good drawing expert. If this is the cell where I need to put epsilon, okay, sorry. Yeah, if this is the cell where I need to put epsilon, yeah, see this, if this particular arrow, it will travel from here, 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 there will be some character here, and then it will reach here. So suppose I reach this part. As I read this epsilon, okay, since I get this updated now to epsilon, epsilon means empty cell. Epsilon means empty cell. Empty string की तरह वो empty cell read किया है, empty character है. Nothing is read. So nothing is read, nothing to look up. So this second operation will not be performed. As I have this epsilon, second operation is not performed. So what will be the operation that the device would do? Device will now check whether Qj is one of F. It will check whether this belongs to F. It will query. This is the query that it will do. So it remembers this F. That is part of the definition of this device. So it remembers what is F. So it just does again a lookup for whether Qj is final state or not. If Qj is final state, then I have accepted the input. If it is not final state, I reject the input. Okay. So this particular thing is called as tape. Okay, this is infinite tape. And I can write string anywhere in the tape. I just need to move next up to the string is written. As I reach a point where the string is no more, I'll just check which state I am in, whether that state is final state. If it is final, done with. Not final, stop. Okay, so this is how this device performs. Any doubt in construction of this device, working of this device? Okay, we'll look more closely to these things in tomorrow's lecture.